Hello everyone. Welcome to my new video. Today, we're exploring a vulnerable machine called Corpvision. This machine is part of a single series and is categorized as beginner to intermediate in terms of difficulty. To get started, head over to the VulnHub website and download the vulnerable image. If you're new to VulnHub, check out our VulnHub playlist for helpful videos. Once you've downloaded the image, the next step is setting up the server in VirtualBox. This process is quite simple and involves importing the OVA file into VirtualBox using the Import Appliance feature. Importing the OVA file into VirtualBox is a straightforward process. Here's how to do it. Launch VirtualBox. Go to File in the menu bar and select Import Appliance. Choose the downloaded OVA file from your computer. Click Next and review the appliance details and settings. You can adjust them as needed. Click Finish to start the import. The VirtualBox attempts to import the virtual machine, an issue arises, leading to automatic aborts importing. Let's troubleshoot this. To resolve the problem, we'll need to extract the OVA file and manually install the VM. Next, we'll rename the OVA extension to zip. Since direct renaming isn't possible, open command prompt from this directory by typing cmd in the address bar. This will open command prompt in the same directory. Use the dir command to list all directories and files. Then, to rename, utilize the ren command. With the OVA extension changed to zip, we can now extract it using WinRAR. After extraction, I discovered several helpful files, including 2 VMDK files. Our next step involves creating a new virtual machine. In VirtualBox, click on New to create a new VM. Name it Corpvision 1 and select the operating system type as Linux and set the version to other Linux 64-bit, since we do not know. Proceed by allocating RAM size for your VM and click Next. Select Use an existing virtual hard disk file and import the VMDK file extracted earlier. After clicking Next, then Finish, the setup is complete. Once the import is finished, you'll see the Corpvision vulnerable machine listed in the VirtualBox Manager under the VulnHub group. Now, go to Settings, then Storage, and add the second additional VMDK file. Now, change the network adapter to host only. It's important to ensure that both your Kali Linux machine, used for attacks, and the vulnerable machine are connected to the same network, so make sure they're both connected via host-only adapter. Now, try starting the VM again. Finally, you'll notice that our vulnerable machine is ready, with a login prompt awaiting. Let's dive into the fun. Enumeration. The initial step in our attack is enumeration, which involves identifying the IP address of our target machine using netdiscover. To execute this, open a terminal and run netdiscover-i followed by specifying the network interface name, which in this case is ETH1. From the scan results, we've obtained our target IP address, 192.168.95.17. Next, we'll conduct a network scan to identify open ports, a crucial step in the enumeration process. This helps us understand the attack surface and strategize targeted attacks. We'll use the popular Nmap tool for this task. Run nmap-sc-sv followed by specifying the IP address. In this command, -sc is used to perform a script scan using the default set of scripts, while -sv enables version detection, allowing us to identify which versions are running on which port. After completing the network scan, we found 2 open ports. The port 22 TCP runs an SSH service, indicating that with valid credentials, gaining login access to the server will be straightforward, and port 80 TCP runs an HTTP service, suggesting a vulnerable website is hosted on the target server. Now, let's explore the content of the website running on port 80. To look at the contents ourselves, open a web browser of your choice, and navigate to the target's IP address in the URL bar at the top of the window. Upon visiting the web page, I discovered that it uses a bootstrap responsive design, which I confirmed using the Wapalizer tool. However, the visible content on the page doesn't provide any valuable information. To explore further, we can inspect the page's source code by right-clicking on the page. But, this too doesn't reveal anything useful. To continue our investigation of the target URL, we will perform directory busting to uncover hidden or hard-to-access directories in pages. For this task, we'll use the GoBuster tool with the following command. Where GoBuster dir is used to instruct GoBuster to perform directory busting. The -u is used to specify the target URL we want to explore. -w is used to provide the path to the word list containing common directory names to try. Using a directory busting tool, we have identified various directories. One directory, static, appears suspicious upon initial inspection. Upon exploring the static web directory, we find that it contains files and directories with some level of access permissions. However, this exploration hasn't provided any immediate clues for gaining a foothold. To expedite our investigation, we'll use an automated web vulnerability scanner. Previously, I created several videos on this topic, which you might find helpful if you're interested. For this task, I will use Acunetix, a web vulnerability scanner known for its simplicity and effectiveness. If you are not familiar with Acunetix or need instructions on how to install it for free, please visit my blog. To start the Acunetix services, open a terminal and type service Acunetix start. Next, open a browser and navigate to the Acunetix default web page, which runs on port 3443. Add the target URL for scanning and save it. Select the full scan option to ensure a comprehensive check. From the Acunetix scan results, I found two severe vulnerabilities: cross-site scripting, XSS, and server-side template injection, SSTI. While the XSS vulnerability is not particularly useful in this context, the SSTI vulnerability might allow us to gain a reverse shell. Let's proceed with exploiting this vulnerability to gain further access. Foothold. To exploit the server-side template injection, SSTI, vulnerability, it's important to understand how this vulnerability works. SSTI happens when user input is embedded into a server-side template in an unsafe manner, which allows an attacker to execute arbitrary code on the server. In this scenario, the vulnerability is found in the name field of the contact form located on the contact page. This means that any data entered into the name field can potentially be used to inject and run code on the server due to improper handling of the template input. Now, let's confirm the vulnerability. Upon reviewing the attack details provided by Acunetix, I discovered that the name field is vulnerable. This means that by injecting curly brace 7x7 curly brace into the name field, along with other necessary details, we can make the server evaluate the expression, resulting in the value 49. Since the output is 49, the vulnerability is confirmed. Next, it's time to exploit the vulnerability. To exploit this vulnerability, you need to determine the template engine being used. Common template engines include Jinja 2, Python, Twig, PHP, and others. Given the response format, which looks like HTML with Python-like syntax for expressions, it's likely a Python-based engine like Jinja 2. To proceed, we need to inject payloads to gain a reverse shell. For this purpose, I will use Burp Suite to analyze the behavior of the injection payload on the target. First, launch Burp Suite from the Kali menu. access the Proxy tab, and activate Intercept mode to capture target requests. Now, configure the browser's proxy settings using Foxy Proxy. Switch the proxy to Burp Suite within the Foxy Proxy extension. Now, reload the page to intercept the request data, then send the captured request to Burp Suite's repeater tool. It's time to send the captured request to the repeater tool in Burp Suite. Upon sending the request, we got the result of the request in the response section, which means it is working. Next, let's inject a payload to execute code via SSTI. To confirm the vulnerability and test code execution, try injecting open curly braces, request.application._builtins_builtins_import_. Open parenthesis, single quote OS, single quote, close parenthesis, .popen, open parenthesis, single quote ID, single quote, close parenthesis, .red, open parenthesis, close parenthesis. Close curly braces, close curly braces. This payload will execute the ID command on the server. In the response, you can see the current user information, which is www data, confirming that code execution is possible. Since this is working, let's proceed with gaining a reverse shell. To achieve this, we need to inject a payload that sends a shell back to our attacking machine. For this purpose, I will use a Python reverse shell script. We need to replace the IP address in the script with our Kali machine's host-only IP address. Next, paste this payload into Burp Suite, as shown. Before sending the request, we need to set up a listener using Netcat. Now, click on Send to check if we get a reverse shell. Unfortunately, it did not work. I suspect this is because the request is automatically decoded from the URL form when sent. So, let's encode it and try again. Still, it is not working. There is another way to send the request, using the curl command line utility. Let me craft the curl command. After modifying and trying a few commands, we finally got the reverse shell. If you are unable to craft the curl command, consider using AI tools like ChatGPT. Since we have the reverse shell, let's make it interactive. Let's check if Python is available on our target. Yes, it is. Now, change the terminal type to term. Great, it's working well. Next, let's see if we can access the user flag. Unfortunately, we don't have sufficient privileges. Let's see if we can switch to the user Steven. However, after trying various methods, I couldn't find any clues or execute any shell commands effectively. I encourage you all to try your luck and find a way to obtain the root flag and the user flag. Remember, brute force attacks are not possible because the target does not allow SSH connections from any other IP address. Additionally, local privilege escalation is not working because the GCC compiler does not have sufficient permissions. Keep these points in mind. If you find a solution, please send a video or a copy of the output to my email or Instagram. See you then. If you have any doubts or queries, write to me in the comments section.